We're looking at lesson 66 today. Finding perimeters and areas of regular polygons. Yep. Yes, we are in geometry. We deal with a lot of shapes. No, not the beginning of the year, but now we do. The whole year's a lot of writing. Alright, so just looking at these pictures, you don't have to draw them. But what happens as the number of sides of a polygon increases? Yes, angles get larger. It looks more and more like a circle. Y'all see how the decagon looks a lot like a circle? The most anyone's done has been a 96-sided figure. No. So this is a 15-sided figure. What does it look like right now? Now do you see that it's not a circle, but it still looks like a circle, right? Yeah, that's a 15-sided figure. That's as far as it goes. Alright, so each regular polygon has a point within it that is equidistant from all of the vertices. And it's called the center. Just like a circle has a center that's equidistant from the sides, the center of a regular polygon is equidistant from all the vertices. The central angle of a regular polygon is the angle whose vertex is the center of a regular polygon, and the sides pass through consecutive vertices. So I've got a picture for us to look at. So this is our center. This is called the central angle. How many central angles would I have of a pentagon? Why 5? Because there are 5 sides. How would I find the measure of this little angle? On 360 divided by 5. There are going to be 5 of them, and they're all going to be congruent because it's a regular polygon. Then they wouldn't be the same. They'd still add up to 360, they just wouldn't be the same. You're making it... She was really laughing at you. Because you were making a funny face. And he probably is going to say, I wasn't trying to make a funny face. But you were like... Alright, so the perpendicular distance from the center to the midpoint on a side is called the apothem. Awesome. Yeah, that's Alright, so let's practice saying this word. Apothem. Come on. Apothem. Apothem. Everyone has to say it. Come on, guys. Opossum.
Opossum. Oh, say it.
Okay, so it goes from the center to the side. And you're going to want your opossum to find the area of your figure. Kinda. Yes, it always is perpendicular. And it always goes to the midpoint. That's what makes it perpendicular. Okay, so we want to first find the perimeter of these regular polygons. If you can't do number 1, or the first one, so it's a regular polygon. So what does that mean about all the sides? So what is the perimeter? 28 centimeters? Okay. What about the perimeter of a regular pentagon with side length of 3.2? 16 meters? Y'all see how that works? Okay, good. So this is our area formula for a regular polygon. Area is 1/2 AP. A is opossum. What do you think P stands for? Perimeter. That's the opossum. Yeah. Area equals 1/2 your opossum times your perimeter. Just regulars. They're not going to ask you to find the area of a non-regular one, really, other than like a rectangle. Oh, it was like 100 years ago or something. I don't know. I mean, it was a long time ago. It might have been further back, like 18th, 17th century. I just know he did it because he was talking about a proof with it. He used it for some sort of proof. All right, so we want to use the opossum and the perimeter to find the area of the regular polygon. So our formula is area equals 1/2 AP. What is our opossum? What is our perimeter? Why 40? 8 sides, they're each 5. Okay, so what would be our area? Y'all see how that works? All right, so let's look at another one. Yeah, did I not put square? Yeah, meters squared. All right, so now we're going to use the opossum and perimeter to find the area of a regular hexagon with a side length of 4 centimeters. So what are we going to need to do on this one? Okay. So we got to find our opossum. So I'm going to do a 6-sided figure. What can I fill in? Okay, the center. It's right there. Okay, that's my opossum. What's the length of it? So that's 2 and 2. It is a 30, 60, 90 triangle. What is the measure of each of these angles? It is 60. So each of these two would be how much? And then that would make this angle 60. So what can we use? Okay, so this is my 60-degree angle, and this is my 30. Where does my 1 go? My 2. Square root of 3? Okay. So what ratio would I set up? 2 over 1 equals a over square root of 3. So what is your apothem equal? Okay, good. Now what? Okay, 24 squared roots of 3 centimeters squared, or what is that as a decimal? 41.6. .6 centimeters squared. Okay. Let's look at another example. Find the area of an equilateral triangle with a side length of 7 centimeters. So we're going to practice using the 1/2 AP formula on a triangle just to show you how it will work. You've found how to find the area of a triangle before, right? Okay, but we're going to practice using the apothem. So that's the center. So there's my triangle. What is this angle right here? It is the central angle, but what is the measure of it? 360 divided by 3, which is 120. So when I cut it in half, what does it become? And this is A. So the length of a side is 7, so what is this side? 3.5, and this side? 3.5? No, we're going to find our apothem of the big triangle to find the area. Yeah. So what is our apothem? Well, what are we going to do? I mean, if you know it, you don't have to draw it. Where does the 1 go? Where does the 2 go? And the 3? Or the square root of 3? All right, so what proportion would I set up? Okay, y'all see how that works? So you should have square root of 3, A equals 3.5, and then divide by the square root of 3, which is what as a decimal? Any questions on getting the apothem? Okay, so area formula is 1/2 2.02 times what? The perimeter, which is 21. Okay. So what is your actual answer? Okay. Centimeters squared. And you would get the same thing if you did 1/2 base times height. But y'all see how that works? Even for a triangle? Yes. I don't care how you're going to do it. It doesn't matter to me. I just wanted to show you that it would work for a triangle too. Okay? All right, so see if you can find the perimeter of that octagon. All right, who wants to go write it on the board? Do you agree? Okay. See if you can use your area formula for the regular polygons to find the area of the pentagon. All right, are y'all done with this one? No? Yes? No? Who wants to go write the answer for it? I'll go over that later. All right, do you agree with Jamar? Okay, what did you do? Mm-hmm. Is the apothem. You do 1/2. You tried to find your own apothem? Okay. All right. See if you can find the area of the hexagon.
There you go, you got an A. Tomorrow, what kind of first day? move on back to your seat.
Alright, who wants to show how to do part C? Yeah.
They solve off.
Alright, y'all agree we do more?
Do it all at the time?
No, whenever you made it to the top, you always fall back. That two guys that one like little weird like muskrat thing.
Alright, any questions on C? Okay, what about D, the area of the equilateral triangle?
I got 2.35.
Wait, on B?
Those are close enough. It depends on where you rounded. Alright, any questions there? Okay. Go ahead and clear your desk for your test corrections in.